MathGenie.
In this video, I'll be explaining how to solve complex divisibility problems for number 11. As you can see on the screen, I have two different problems for this video because I think both of these problems were very important and they're pretty quick to solve, so I just combined them into one video. If you haven't watched my previous videos for the divisibility problems for number 11, I will link those two videos, actually 3 videos, in the comment section down below for you to go watch before watching this video, because watching those videos before this video will help you understand this video better. So I highly recommend you to watch those videos that I will link in the comments down below first before proceeding with this video. Let's look at the first question. Find the largest 5-digit multiple of number 11. Well, just some recap again. The divisibility rule for number 11 says that the sum of the alternating digits subtracted should either give you 0 or the multiple of 11 as an answer. So by using that divisibility rule, let's try to solve this question, right? So the largest 5-digit multiple. Well, the largest 5-digit number is obviously 99,999, right? Because after this number is going to be 100,000. So this is going to be the smallest 5-digit integer. Well, we want the sum of the alternating digits to be equal according to the divisibility rule. So let's actually try to add this up. So it'll basically be 9 plus, actually, let me indicate the color so it'll be easier to actually notice. So we have the alternating digits here. So we have 999. That's one set of alternating digits. And the other set, let me indicate in pink, will be these two other digits. So the sum is obviously going to be, the sum of the yellow digits is 27. Minus the sum of the pink digits, which is 18, which gives us 9. Well, is 9 0? No, so we can't do that one. Is 9 a multiple of 11? No, it isn't. So we obviously know that 99,999 is not a multiple of 11. But let's take this number into consideration. Well, what we know is that we need to have this the one set of alternating digits minus the other set of alternating digits should either give us a 0 or a multiple of 11. So what if we change this number here to 0? Well, then that will make sense because as a result, we'll get a number 99,990, and we know that the alternating digits, which is going to be 18 here, minus 18 here, is going to give us 0 as an answer. So that works. So we automatically know that the largest 5-digit multiple of 11 is going to be our answer. 99,990. And we know this is going to be our answer because if we add 11 to this number, we're going to get 100,001, which is also a multiple of 11. Let's move on to the second question. The second question asks, find the smallest 5-digit multiple of 11 greater than 90,000. So while in problem 8 it asked for this largest number, now we're looking for the smallest 5-digit number greater than. Pay attention to the restrictions. It has to be greater than 90,000. So let's take that into consideration. Well, we again have to use the divisibility rule to solve this question also. So we know that the sum of the alternating digits have to have a difference of either 0 or 11. So let's start here in 90,000. Well, this is the smallest number. This is going to be the boundary, right? So our number that we're going to get has to be greater than 90,000. So let's first look at 90,000. Let's see what 90,000 is. So 90,000, let's add up all the digits. 90 plus 0 plus 0 minus 0 plus 0 is going to give us 9. So this is obviously not a multiple of 11. Now let's try a different number. Well, we know that 9 is 2 units away from 11. And if we get 11 as our answer, that's going to make the number divisible by 11. So since we're 2 units away from 11, let's add 2 to 90,000. Because as a result, we'll get 90,000 and 2. So let's see if this number is actually divisible by 11. So we're going to do 9 plus 0 plus 2 minus 0 plus 0, which will give us 11 minus 0, which is 11. And that tells us that this number here, 90,002, is going to be divisible by 11. Because, again, our rule says that we can either get 0 or a multiple of 11 as our answer. And 11 is a multiple of 11, because 11 times 1 equals 11. So the smallest 5-digit multiple of 11, greater than 90,000, is going to be 90,002. And even if you didn't automatically kind of catch that since this is the number, the remainder is 9, you have to add 2 units to make it to 11. Well, you automatically should think, hey, there's a remainder of 9, which means that if I add 2 units to it, that's going to make this equation equal 11, which is what we need. So you should definitely go ahead. A switch should flick in your mind to tell you that this 0 should be replaced by a 2. Because we're looking for the smallest number. Well, if it asks for any number, we can just, put other numbers, even like, for example, we can have other numbers like 90,200, right? Because we just need a 2. We just need that extra 2 in the equation. But the reason we didn't do that is because we're looking for, again, the smallest number. There's a restriction. So always pay attention to the question before writing down your answer. Thank you for seeing to the end of this video.
Math Genie.